Hey friends, my name is Vivek Sharma, and today we can cover this interesting problem that's called serialize and deserialize binary tree. Serialization and deserialization is the process where we can correct in serialization, we can convert basically the character stream into the byte stream, and then we can just read back from the byte stream to the character stream, and that's called the deserialization. So serialization is converting character stream to byte stream, and deserialization is the reverse, when we just want to read from the network and we want to convert it back from byte stream to the character stream. And this process is useful whenever we are just doing remote call, or we are just doing a lot of network call, right? So during RPC call, like remote procedure call, and lot of RMI calls, remote procedure invocation and all. So in that those processes, basically we have to call a lot of times some APIs over the network, right? And we have to transfer some data over the network. So that's where it's useful. And here what we are trying to do, we are trying to do the same thing, serialization and deserialization with the binary tree. So let's see, for example, we have been given some binary tree. Let's say this is the binary tree, right? 1 2 and 3. So I have been given this root node, and if I have to serialize this binary tree, then basically I can serialize in some string. And what I can do, I can just take this root 1 and root dot left 2 and root dot right 3. So I can just convert it to 1 2 3. That's my string, right? And whenever I deserialize, I will just take this string one by one and I can convert it back to the tree. So to do that, I have to split these characters based on some splitter or something, right? So the reason of doing that, because in during the deserialization process, I will have no clue that how to deserialize or how to identify these characters, right? So basically during serialization itself, what I can do, I can just take these root and left and right, and I can just insert some kind of splitter here. So let's say 1 and then comma 2 and then comma 3, something like that, right? And during deserialization, I can just split based on the comma, and then basically I can just easily deserialize the same thing. So that's one point. Another thing is, let's say for example, I'm having root is null, right? So uh, uh, if root is null is given, right, then in that case what I will do, I can just in my string, so in my string output, I can just insert hard-coded null or something like that, so that during deserialization I can just see this hard-coded null and I can just figure it out. Okay, this is the null, it means my root should be null, right? So something like that, we can just do that serialization and deserialization process, and that's how we can go forward, right? So this approach is pretty straightforward. We can just quickly code in the same way. So let's see how we can do the same thing. So serialize, we can just take our one string, let's say string builder, and this is new string builder, and let's say this is serial helper. Serial helper will convert for us this root to this string builder, and then we can just return this string builder that we already built, right? So root comma sp, and let's say this string builder, right? And this string builder serial helper will have this tree node root and this string builder sp. Okay, so what we can do, if my root is null, then basically string builder dot append I can just append some null, hard-coded null, so that I will know that this is null. And definitely I can append some splitter as well. And the reason to do so is basically so that I know that what's the separator or what's the splitter, right? And in the else part, I can just go ahead and I can just add this. So let's do this, builder dot append root dot val, and let's call it recursively root dot left comma sp, and the same thing is for right child, right? Okay, and that's it. So one modification I can do it here in the appending here, right? So every time I'm appending this root dot val, I'm appending one splitter as well, that's a comma, right? So that's it. I mean, that's the my serialization part. Now the same thing for the deserialization, the way I'm just serializing, the same way I can deserialize as well. So we can just get another array list after splitting this data by the comma, and to do so basically we can take some kind of the queue structure. So let's understand this from here. So let me clear the board and let's see. So let's say I'm having 1 comma 2 comma 3. So this is, let's say, my serialized string, right? Now I have to deserialize this back to the back to my binary tree, right? So what I will do, I will just split this in one array. So this will be 1 2 3, right? And if this is 1 2 and 3 and this is my queue, what I will do, I will just check this first node, that is 1, and that's basically this is basically not null, right? So what I will do, I will just create the root node as 1 here, right? And then I will go to this, and what I will just insert this value to the root dot left, and another value is the root dot right. That's what I will just keep doing sequentially, because that's the order I already built in the my string builder as well. The same way I insert it, and the same way I'm just taking these strings out and I'm building my binary tree. So in this case, this will be the binary tree 1 2 3, right? So let's follow the same approach, right? So this is the output. So let's do the same thing. Let's build one queue, and let's say this is queue and then new linked list, right? And queue dot add all data dot split, and split based on what? Based on comma, right? And then let's say arrays dot as list, right? So this is array dot as list, and what we can do, we can just deserial helper, right? And we can just pass this linked list this queue, that's it, and private, and this will be tree node. So this is tree node deserial helper, and in the deserial helper itself we can take one queue and that is the string, and then let's say this is queue, right? Now let's pop from queue itself. So let's say this is my value, right? And let's check if my value equals or dot equals, right? So the reason we are doing dot equals, because it's a string, right? So we want to check the value but not the reference, right? So that's why we are doing this. And if it is equals to null, right, then what we are going to do, we will just go ahead and return null, because in this case our root is null, right? If root is not null, then basically simply just create the root, right? That as we discussed, right? So root new tree node root, and then basically let's use this value right? And root dot left equals to what? Let's call it recursively deserial helper, and q, and root dot right equals to deserial helper, and then this is q, right? And after doing this, let's do this return root. So here we need to convert this to the integer itself because this is a string, so we can do integer dot parse int, and let's convert this to the integer, right? So I think that's it, right? So this is null, and then basically we are splitting on the based on the comma, and if it is null we are returning null. And so I mean that should be pretty much it, right? And let's try to run this for the compilation error, if any. So 1 2 3 4 5, I think we should be good. Let's try to submit and let's see if it is working. Okay, so I think we should be good. And for the time and space complexity for this problem, so let's say time complexity, so time complexity for serial and deserialization for both, it will be n, right? Where n is number of items, right? And it's basically for both n for serialization and deserialization, because we are iterating basically n number of times, right? And number where n is the number of items, and space complexity is also n, and where is n is number of items. Those items can be in the form of a string or they can be the number of nodes as well, right? So yeah, and we are not using any global variable for the separator for comma and null, because they have mentioned it here. Do not use class member global static variables to store the states. Your serialize deserialize should be stateless, and that's the reason I avoided this. Otherwise this comma or null we can use as a global variable as well, but it's not needed. So this is we can just tell our API that okay, this is our null, hard-coded null, and this is our separator. So based on that, basically they can just use this based on the serialization and deserialization. So if any question or any confusion, just feel free to ping me or just leave some comment, then probably we can just look further, or if you have some better idea, just let me know. Thanks a lot guys, bye.